the liquid filtration, if you see, as compared to air filtration, it is a huge. Okay, if you compare them, and complexity is more in the case of liquid filtration as compared to air filtration. Okay, and you can get huge number of appliances, machine for liquid filtration as compared to air filtration application. Air filtration application is much more simplified as compared to liquid filtration applications. One of the primary reason is that whenever we talk about the air filtration or liquid filtration, liquid viscosity is more, density is more. So whatever is the applicability for air filtration, that may not be similarly applicable to liquid filtration. Suppose if you give more focus on single fiber theory in case of air filtration, but single fiber theory can have little relevance in the case of liquid filtration application, because of density is very high for the liquid as compared to air, and also the viscosity is also high. Now before I proceed, I like to show some of the materials which is used for liquid filtration application. Okay, so this is the engine oil filtration. So basically oil moves from inner side and the clean oil will move from the inner side. Outer side the oil will come, and from the inner side the oil will go to the engine. So here it is a cartridge. It is known as cartridge because it is a one system, one house, which can be fitted very easily in a system. Okay, so and why it is splitted? Splitting is done because you can get larger surface area in a given space. So that is the primary reason for the splitting. Now if you see the other type of filters, okay, like the engine air filter, this is another engine air filter I am having. So same way that, okay, it is not coming out. Okay, so this is also built-in cartridge. Okay, that can be fitted. So we can have the similar application for oil filtration. Now other type of filter media I like to show, for example in drinking water. Okay, we can have this sort of media. Okay, here also you can have the activated carbon inside. So it can have multiple function. It is not that only it is arresting the particulate matter, but also it can remove some of the contaminants. Okay, smell can be reduced by passing through when the liquid is passing through the activated carbon. So activated carbon is inside this outer layer. Okay, so it will again flow from the outer side and it will go to the inner side. Mostly the liquid flow from outer side to inner side because we can have largest area into that will come into play. And this is a yarn cartridge. You can see this is the developed by the industry. So some micron rating is given for 5 micron rating, means it can arrest the particles which is above 5 micron. So this is again the industry wanted to launch this spunless material in place of this one, because this production process takes a lot of time, because you will have to make the yarn first, then yarn has to be wound onto the package. If you see, yarn is wound onto the package. This can act as a filter medium. So industry wanted to have, why not using the spunless process, okay, instead of in place of this, because yarn manufacturing, then you have to wound it onto the package, then this package has to be used. But here the spunless material can be directly wound onto this package, and this package can be directly used for the similar application. But this sort of material cannot be used when the contamination level is high, because it could be blocked very easily. So this is used for drinking water filtration primarily, because the contamination level will be much lower, because depending on the contamination level we will have to select the right kind of separation unit. Okay, so this is again that is another system developed for separation of particulate matter. Now if you see, I am just showing you one of the pre-filter. This is a pre-filter for air. But why I am showing this? Because this cannot be used for liquid filtration application, because it will be immediately choked. Within few moments it will be choked immediately. So if you see the filter media which is applied for the liquid filtration application, that has to be very compact. I can show you some of the filter material. This is basically oven material, okay, but if you see, this is manufactured in the industry and this is very quite compact oven fabric, which can be used for liquid filtration material. So in one of the very important aspect is that in liquid filtration, stress generated to the media will be very high as compared to air filtration application. The material, if it is made out of normally needle punch and all this spanless, the material will get deformed under the pressure. So unless and until it is very compact, because some of the material also being made which is very compact material, you can see that what is the level of compactness of the material which is made up from non-oven. Okay, so non-oven also is increasingly used nowadays, which has to be very compact. Okay, but if you see it is the stiffness and the level of compactness, it will be very high. Why it should be high? Because one of the problem in the non-oven is that if the particles goes into the certain depth, removal of the particle become difficult, because of the higher viscosity, the particles will be tending towards moving towards the certain depth. If it moves to a certain depth, removal of the particle become difficult. Whereas the removal of the particle will be much easier in the case of oven filter. So for a very long time, the people use the oven fabric and the derivative, different types of derivative for filtration, liquid filtration application, because the easy cake release will be possible. So wherever the sludge content will be very high, so easy cake release is one of the most important property. So easy cake release is possible from this media, and the cake release will be difficult in this case. Okay, but people also trying to develop the non-oven having the finer fiber layer at the top, so gradient media and that sort of development keeps on coming, because so that you can dispose of the cake very conveniently, because disposal of the cake is plays a vital role whenever you are developing this. And again, the depth filtration also matter, because whenever you are operating it for a continuous time and over a large quantity of the sludge, obviously the depth filtration matters a lot. In this case, for drinking water, you can go for depth filtration as because the contaminant is very low. So in a maybe after 6 months, after 1 year, you'll have to change the cartridge. Okay, because depth filtration is very low and saturation of the media will take a lot of time. It may take 6 month time or 1 year time for the saturation. So till that period you can use it. After the saturation period over, you can throw it. Okay, that is the principle of depth filtration, but here it is being repeatedly used, okay, in the cyclic manner, and where the cakes has to be discharged. Now I am showing you the other filter. It is the air filtration, but it is not so much compact. It is used in the industrial scale, and this is the natural color. Remember that we never go for aesthetic look for the filter. This is the natural color of the polymer. It looks like this only. This is used for industrial pulse jet filtration process. This is air filtration process. Why I am showing this? If you compare the stiffness of this one as compared to the stiffness and compactness of this one, that is entirely different. That material will be much more compact than this media. Okay, this is the air filtration media which is being used. Now this one is a link fabric. If you see the size of the particles is large. Normally in the air filtration we don't talk about the large size agglomerates or the particulate matter. But in liquid filtration we go for a large size of the particulate matter, which can be conveniently addressed this, because unnecessarily you should not reduce the size of the pores, because unnecessarily if you reduce the size of the pores to capture large size of the particle, then the flow will be restricted. So we will have to make the balance between the flow, okay, because flow should not be restricted. At the same point of time, we want to get the particle must be arrested. So challenge could be very different depending on the case to case. Challenges is not the same, because it all depends on the contaminant concentration, size of the contaminants, okay, volume of the contaminants, shape of the contaminants. So lot of things matter whenever trying to develop the media. Because sometimes the abrasion property may become important property, because abrasional damage also can happen during the liquid filtration. So we'll have to make choice a proper filter media whenever we are going for certain kind of application. Now this is another liquid filter. If you see, it is a spun bonded material. Earlier was the needle punch, and it is highly consolidated. Needle punch and followed by spun lacing technique. It is a spun bonded technique, very stiff, very compact. Okay, so this can work for liquid filtration for a certain applications. Now, if you look at the broader sense, the liquid filtration, even in the geotextile, we are using the concept of liquid filtration. It is not that in industrial application we go for liquid filtration, but if you look at the geotextile, so there also the concept of liquid filtration is valid. If you see this composite material, inside there is a plastic core, okay, and outside the non-woven material is there. So whenever the liquid flows, so this is used for underground drainage. Whenever liquid flows, it will filter because we are using the media. That's why it filters the large particulate matter, and it will only allow the water to flow in the plane of the plastic core. So that is the important part, because mostly if you see, we make the highway, whenever we are making the highway, the drainage must be mandatory in all highways. But if you see, after 6 months, this drainage is not working because it is not properly, drainage is not being properly made because it is getting clogged. So, but if you are using this one, so open drain is not required. Okay, then again it can filter out the larger particles and it can allow only the water to flow in the plane of the plastic components. Okay, it can be drained out conveniently and it can have longer life. Why I am showing this one in this, because the liquid filtration is not restricted to only the industrial application. It can have vast application, and if you see, this is the hollow fiber. Okay, in hollow fiber also the kidney dialysis, we can make use of this hollow fiber. So through the core part the liquid can flow, okay, dialysis can flow, and we can go for liquid filtration. This also a kind of liquid filtration whenever we talk about the dialysis in the case of kidney failure. Now coming to this, we must have clear definition about the filtration, because many cases, again I have seen that one of the textbook, the title is filtration, but inside it, under the heading of filtration, the author is mentioning about the separation techniques. So that is totally wrong. So filtration comes in one of the technique, okay, under separation. Okay, because filtration means that you need a media, okay, you need a media, okay, so pressure drop has to be applied across the medium. So here it is a media, okay, porous filter cake acts like a filter for suspended particles. So cake filter is not, will happen always. For example, that household cottage that I have shown you, it will not that it will form cake, it will not form cake. Whenever the sludge content will be more, so cake formation will be there. Now, driving force, pressure upstream minus pressure downstream. So that will be the driving force. Flow resistance increases at the filter media, becomes clogged and cake build-ups. So whenever the cake build up and it is clogged, so then the pressure will increase. So every effort are being made that how to reduce the clogging. So that is the, I mean, a lot of researcher work in this particular area, where how we can minimize the clogging, because if you can minimize the clogging, the life could be longer. Next is the fluid flow will reduce in general, because with the time fluid flow will reduce, cake is to be dislodged intermittently for continuous operation. So for continuous operation it has to be discharged. Now if you see that this is the whole type of, different type of the filtration and separation, we can have the continuous medium and we can have the dispersed phase. But if you see in the GAN program, basically we are restricted ourselves to this part only. So liquid is the continuous medium, gas could be CO2, degassing wine, which is possible by removal of CO2. Okay, second case is the emulsion, removal of oil from water. So liquid dispersed phase will be the emulsion, okay, or liquid. So liquid separation is also possible. Okay, so there is a, but the technique and the mechanism for liquid separation is different from liquid to solid separation. The technique is different. And this, most importantly, that most of the cases we go for liquid to solid filtration. So we will be concentrating more on this removal of solid from solution like wastewater, blood, ink, petroleum. So removal of solid from the liquid is also an essential part of filtration. Okay, now here if you see, all are basically separation. Magnetic separation is there. Filtration comes in one of the separation technique. evaporation, distillation. So these are all separation, and filtration is one of the separation technique. So there should not be any confusion. If you write a title of a chapter, there it is mentioned that filtration, and then inside the author is mentioning the separation technique. That is logically not correct. Now if you see the stages of industrial effluent treatment plant, already Dr. Choi shown this. So if you see, there are several stages. Okay, primary treatment is there, secondary treatment is there, but remember these are basically separation technique. Aeration tank, because there may be much more detailing about this. Secondary clarified, aeration tank, and some aluminum sulfate is there, and other chemicals are also being there for coagulation and separation. But these are all separation technique. These are all separation technique. But if you are going for the sludge treatment through the filter press, then here it comes in the point that filtration is important, because here you are using the media for separation of the water from the sludge, because people prefer to dispose the dry sludge, because every industry wants the dry sludge to be disposed rather than contaminated sludge and having water inside it. So dry sludge disposal is preferred in a land. So here you can use the filtration. So it is an example of mixture of separation and as well as filtration. And also you can have the tertiary contaminant, tertiary treatment plant. Okay, so in this case you can see with the time the people also having different types of tertiary wastewater treatment. That is also very important because of emerging contaminants. For example, from hospital we can get the endocrine disrupting chemicals. Because it can disturb our hormonal balance. Okay, so that removal is very important. But if you are not taking a proper precaution, that become a problem. That could be cause health hazard. Similar to that, you can have the microplastic. That can also cause lot of health hazard. Again, it has been seen the microplastic is reaching to the brain. Okay, so that is also possible. It could cause different type of cancer. So we must have to look into different type of tertiary wastewater treatment. Okay, along with the other filtration and separation. I think the concept is clear about the separation and the filtration. Filtration is one part of the separation. Now here if you see, this is again one of the coagulation and flocculation technique where the separation is used. So basically you are using that anionic contaminants are there, okay, and cationic coagulants. Okay, cationic coagulant, so that the charge, because normally if you see contaminants is having the negatively charged, contaminants having some negatively charged. So positively charged coagulants can make them, can discharge the charge present in the material, so they can come closer. They can come closer and finally they can make the flux. Okay, they can make the flux and then they can subsequently make the after coagulation, initially they will coagulate because of the charge neutralization. After neutralization, they will become bigger. If they become bigger, so they can be separated very easily because they will be in a large flocculants are available. So you can see one of the video, then it will be more clear how it works, because here the swabbing material are used for coagulation and separation. This is in picture of the South Africa. The problem is water scarcity is there. Then we can see that how the water can be cleaned. So they are using the swabbing powder in this. Swabbing powder. Okay, that material are being used to discharge the contaminants. You can see that how the water get purified. Okay, so this process is separation process, not a filtration process. Now another important definition is clarification, because mostly we will be using the term clarification where the percentage of content of solid present will be very low, 1% water, weight by volume. For example, in household, whatever the purifier you are using, okay, the cartridge, so it is applicable to this application only. Okay, so clarification being used, so there in the clarification we can also use the membrane filter also. It is very good for the clarification. So Clarification, there are several methods are there: coagulation, flocculation, sedimentation. That way also one can go for clarification. Only the difference in clarification is that the weight by volume, only you can have 1% of material, okay, solid content in clarification. Now one of the example that whether we can define it as a separation or it is a kind of filtration, because here it is the use for oil spill cleanup. So basically we are using the polypropylene fiber, okay, and the polypropylene fiber basically can be used for the oil spill cleanup. So better to define it as separation, because in filtration fluid has to be passed through the porous media. Okay, it is not passing, it is simply absorbing. Okay, it is simply absorbing the oil. That's why it can be categorized under the separation, not as a filtration. So medium action is a act as a barrier, where it is not acting as a barrier. So I am just keeping it because you will get this material just to define that what is the difference between filtration. No, separation again you can, because last example I am showing the textile material is there, but it cannot be defined as filtration because the liquid is not passing through the material. Okay, it is not going to the other side. It is simply being absorbed. The you can say that oil is simply being absorbed. It is not that air. It is not passing through the media. So it is better to define it as separator, not the filtration media. Okay. Now major uses of filter, if you see the gas filter is one of the very big aspect, big area, and you can have also the liquid filter. Some of the application already being highlighted. Now here if you see aqueous fluid filter will be there, hydrocarbon filter will be there. If you see this is a huge class or huge application, you can get the water treatment plant, we can have drinking water filtration, beverage filtration, okay, aqueous food filtration, medical filtration. So whatever oil is also there, okay, swimming pool filters, aquarium filter, pharmaceutical application. So you can have huge application. Hydrocarbon fluids, so there also you can have petroleum, aviation or diesel fuel filter, hydraulic fuel, edible oil filtration, engine filtration. So basically you can have two broad classes of filter. One is the hydrocarbon filters and another one is the aqueous fluid filter. So it can be divided into two different classes, and that also I have initially mentioned that for health and survival it is very important. Okay, pharmaceutical, you can have lot of application, industrial development also, we can have significant application, and environmental protection, food nutrition, everywhere if you see the role of liquid filters is very important. Role of liquid filter in energy sector is also quite considerable. Now here it shows that what are the application and challenges for air filtration and liquid filtration. Okay, air is compressible, low density, liquid is incompressible and high density. The type of contaminants in the case of air filtration, that is different from the liquid filtration. So contaminants type will be different. Driving force will be pressure drop and pressure difference. Okay, fibrous material will be different in both the cases. Okay, again in the liquid filtration you can use sand, membranes. Membrane is also being used in air filtration also, but the type of media will be differently designed. Okay, application is clean room, hospitals, HVAC, automotive. In the case of liquid filtration application, pharma, semiconductors, drinking water, wastewater, these are the application. And challenges is that maintaining airflow is the challenges for air filtration, filter clogging, that is also a problem. Gaseous removal, that is also a challenge for air filtration. In the case of liquid filtration, high pressure, energy cost, fouling, these are the problem. Similar problem is there in the case of liquid filtration. The life of the filter media based on the how the clogging takes place, whether the pores get blocked or not. One point I like to mention that if you look at the pore size can have little relevance in the case of air filtration, but pore size depending on the contaminant, it can have important role in the case of liquid filtration. Why I am saying this, because suppose if you, because morning also one of the professor was telling about the mask. Okay, mask, if you see, normally we cannot reduce the pore size in the mask below 15 micron. Very difficult. We cannot use membrane because the breathability will be a great issue. Okay, so we can use the mask where normally the pore size is 15 micron. Now think about, if you see the COVID virus, why the COVID virus is getting arrested, the size of the COVID virus will be as small as 40 nanometer only. Okay, lower size. Higher size it could go up to 140 nanoscale. Now, this much of size, you cannot think of that pore size you would want to maintain of having that size. Now, how the person is getting prevented from the virus? So that is the point, because we cannot correlate it directly straight away from the pore size and the particle size, which is having lower knowledge. I can say that people just try to predict or visualize. They always try to think in terms of pore size and particle size. It is not so simple. It is not so straightforward. Main thing is that the pore size in the case of non-woven structure is tortuous, and the small size, fortunately the very small size shows the Brownian motion. So one hand it shows the very Brownian motion, zigzag motion, it is not showing the straight motion. Another side, the pore size in the non-woven, that's why the non-woven is preferred over woven fabric, because woven fabric can give you the straight pores. So likelihood to get into the lungs would be more in the case of woven fabric, because the straight pores is more, whereas in the case of non-woven you can get the tortuous pores and the particles or the virus showing the zigzag motion because of the Brownian motion. So you'll have to understand the mechanism very clearly, because and many platform I have seen that in fact even in the research presented in international forum, they are saying that their pore size of the non-woven is 40 micron, and they are talking about the separation of the particle below 2.5 micron. How we are talking a separation of separation of particles which is below 2.5 micron by a pore size of a material having 40 micron? Although there are people trying to compare this material having 40 micron, another material is 50 micron. So 50 micron will be not superior as compared to 40 micron. What the relevance of comparison? 40 micron and 50 micron. Because in both the cases, it is much higher than 2.5 micron. So that doesn't hold good. That is the point. So mainly the area matters, because lot of parameter which can have influence, the area matters, surface area matters. Okay, and the nature of pores also matters for the arresting the particle. Now, if you see the broadly filtration process contribute to the following. If you see the purity of the product, injection liquid, okay, it is highly filtered. If you see the vaccine, it was highly filtered, and multi-stage filters are being used for purity, because every drugs are being made in proper filtration process. Otherwise, what will happen if the people are going for shortcut method? You know what are the elements we are getting inside our system, because we maybe get rid of our fever, but we get into the other sort of problem, because kidney act like a filter, and you get into the other sort of problem because it is not properly filtered out. All the type of, because filtering obviously costly, so many cases the people try to bypass the filter to make it low cost, okay, and to make the cost down, but that should not be the practice. Okay, so next is the functional performance, the removal of anionic particles during creation of drugs. So functional performance is important. Saving in energy, removal of particle from the fuel. Next video I will show you how the energy saving is possible. Improvement in product and process efficiency, removal of contaminants from wastewater, protection of machine, instrument and their components. This is another important aspect, recovery of precious material, for example gold, silver. If you go through the process, you will find that there also the liquid filtration plays a vital role. So this is the, and finally one of the most important is the environmental. That point I should write over here, environmental protection. This is the another important aspect why we are going for filtration. Now here you can see that how the it works. This is the injector nozzle. If you see at the top,
The fuel filter has to be changed regularly to ensure the full filtration efficiency. Choose guard filter if you want to meet today's requirements on fuel quality. Guard filters can now filter out almost 100%.
So it is again outside to inside filtration.
With the newly developed multi-grade, multi-layer filter medium. The multi-layered structure of multi-grade means that it achieves the previously unheard filtration efficiency. Guard filters ensures maximum engine output and prevents coring at the injection nozzle and corrosion damage to the injection system through ideally filtered.
See, injector nozzle should not get blocked. If there is a particle, injector nozzle will get blocked. That is the problem.
Low-quality filters often have a whole range of disadvantages. For example, casual filter media cannot hold back fine dirt particles. They also have a much lower dirt absorption capacity and have to be changed more often because they clog up more quickly. Fuel is unpumped against a high resistance. This could result in the
See, the injector nozzle are getting blocked.
The
If it is blocked, obviously it will
filter medium
not perform properly.
can enter the injection system almost completely unfit. Scoring of the injection nozzle and the wear of those engine parts lubricated by the fuel can be expected if the filter medium is damaged. This has a serious effect on the injection process and the engine output drops. Guard filter can prevent this and have an additional important function in diesel engines. They filter out water. The multi-layer filter medium, multi-grade, can filter out almost all the water in the fuel. The water droplets fall into a collective chamber. The water is carried out from here by a drain device. This ensures reliable protection of the injection system against corrosion damage. Low-quality filters often have an
Okay, so here if you see, by this filter we should be able to remove particles. Particle removal mechanism is different from the removal of water. Okay, because the coalescing technique. So next few slides I will show you the coalescing technique, how it works, and also it can remove the paraffin. So all this can be removed by this type of filter. Now if you see, this is the kidney dialysis system. Okay, so already I have shown you the how the hollow fiber look like. So here also the role of filter is very important. Now pharmaceutical application, if you see, so you can have that already I have mentioned about the eye drops, okay, Listerine mouthwash, okay, sterilization of products. So this area pharmaceutical application we can make use of filter. Now you can see the purity of the product to pharmaceutical application. Basically we want to get the protein powder, but in the process you are having the three stages filter. One is the microfilter, second is the ultra filter, and then meta filter. Okay, so you remove the lactose, reduce through ultrafiltration, unwanted impurities also being reduced so as to get the protein powder out of this whole system. Basically this is the milk whey, okay, from this is the derived from the milk, liquid whey, it is derived from the milk, and we go for multi-stage because in market also you can see the protein powders are available. So to get the protein powder, this is the multi-stage filtration process. So what I am trying to say, even in the for drugs development, it is not a single stage filter. There is a multi-stage filter plays a vital role. Now this is the geotextile application. I have shown you one of the picture, not taking so similar picture. So there also it takes the role of filtration is very important. Now if you see the natural cake formation, it might take 10 years time for geotextile, but in the case of liquid filtration, within second the cake will form. That is the difference. Here also this is also kind of filtration that will happen in the case of geotextile, but in the case of whenever we talk about the liquid filtration, cake formation will be very rapid, quick. Within second the cake formation will take place. And this is the river embankment use, and this is the band drain. I am just skipping off this slide because this is the soft soil, we can have filtration. We can also use the geotube for filtration, because if you have the water contamination in the sea, that can be pumped inside the geotube. Geotube will be large inside. Okay, whenever you are pumping inside, so what will happen? The sludge will move inside, the liquid will move out from the geotube. Okay, only the solid will be inside the geotube, and the solid material along with the geotube can be disposed in the landfill area. That is the another kind of development. Okay, so if the seawater can get contaminated, we can make use of geotubes in that application. Okay, now if you see the efficiency of the particle separation, so different kinds of filter media can different have the particle separation. We can go up to 200 micron separation. The link fabric I have shown you, so it can separate the large size of the particles. We can have oven wire which can separate the 100 micron particle. We can have non-oven, we can have oven cottage, so which can separate even the small particle. Membrane can separate the lowest size of the particle. If you see over here, zero 0.1 micron particle. Again, it depends on membrane to membrane. So several membranes are available, but the typical size could be 0.1 micron and below 0.1 micron particles can be separated by membrane. So different types of membranes are filter media is there, and their capabilities will be different depending on the application. We can choose the right kind of media. Now again, if you see the comparison in terms of difference in mechanism, okay, gas low density compressible, high mobility, okay, in liquid filtration high density incompressible and strong viscous drag, okay. Different liquid properties affect particle movement and capture. So this is one of the very important comparison of between the air filtration and liquid filtration, because that's why the mechanism will be also very different whenever I talk about the liquid filtration and air filtration. If you see here, the particle size range 0.001 micron, very low size of the particle to 100 micron particles. Okay, above 100 micron particle will be rare in the case of air filtration, whereas in the case of liquid filtration, it can start with 0.0001 micron. In the case of RO, it can go up to millimeter, okay, very large in size. So there also the liquid filtration is applicable. So the application range is quite different in the case of air filtration and liquid filtration. Mechanism I will explain in detail. Mechanism will be also different. Okay. Now gravity role will be minor in the case of air filtration. Gravity role will be major in the case of liquid filtration. And surface both, although here I have written depth filtration, but surface filtration is also very common if you are talking about the industrial filtration. And pressure drop, if you see in the case of air filtration, it will be lower as compared to liquid filtration. It can go up to 1 bar or more than 1 bar. kPa to bar means it is 100 kilopascal. More than 1 bar means 100 kilopascal. So it could apply the huge amount of pressure on the media. So media has to be made according to that. Otherwise, if the media get deformed, so it will not be able to function properly. Now mechanism of filtration, if you see the broad aspect of the mechanism of filtration, it is not only restricted to particle capture and interment, because mostly we talk about the particle capture and interment whenever we talk about the liquid filtration. But basically it can also have the absorption phenomena, coalescing, gel removal, electrofiltration and extraction. We will say one by one. So this is the solid liquid filtration where we remove the particles. Okay, I will explain the mechanism later on, but this is the solid liquid filtration. Whenever I talk about the absorption, it is the surface phenomena. Activated carbon can absorb, okay, but obviously it can be in between the two layer of fabric. You can have activated carbon like I have shown you in the so whenever the material is passing through, it can absorb the gaseous matter in the case of air and some of the contaminants, or in the case of liquid filtration application. So charcoal is basically used because charcoal is easily available and it is having lower cost. Absorption means this is another mechanism. Absorption means it absorbs the oil from the water. Okay. Now if there is a oil and if you are having water inside in the fuel, it can selectively absorb the water in it. Okay, it can selectively absorb the water in it. So that is the purpose of the super absorbent textile. So that is sodium polyacrylate for filtration of water extraction. So that is used in a large number of applications where if the fuel is contaminant, in the fuel if you are having water contaminant, the water can reduce the performance of the engine. So that water must be separated out. And how the water is separated out? If you are using the media can separate the particulate matter by simple mechanism. Along with that, media also help in absorbing the water. By absorbing the water, it can separate the water from the oil. So if you see, this is the uniqueness of the super absorbent textile. It can absorb 500 times of its own weight. Okay, whatever of the pure water. Obviously, if the water gets contaminated, obviously the percentage value will be less. Coalescing, this is another technique. So here if you see, the oil water separation is also possible by coalescing technique. So here it passed through the media. Whenever it passed through the media, you can see over here, it will get retarded whenever it is passing through the media, and it will gather within themselves. It become bigger. Whenever it will become bigger, it will tend to float. Initially it cannot tend to float because it will first retarded, it will be arrested by the media. Now media, inside the media, what will happen? That small oil particle will gather. Okay, they will combine themselves. It will become bigger. Bigger oil particle will be lighter in weight. If it is lighter in weight, it will float over the water. So here you can have the pumping device to separate the oil from the water. Okay, so this is the another technique. This is the coalescing technique. This is the different from the other techniques I have referred. This is the another technique where we are separating the oil, but here based on the surface filter. Earlier one was the depth filtration. Sorry, by means of depth filtration means it is moving to the other side. Okay, here it is based on the surface filtration because you want that it's to be arrested on the surface. Whenever it is arrested to the surface, it become bigger and it will tend to float, and pump will be on this side, on the upstream side. This is the upstream side, this is the downstream side. Upstream side the pump will be there, so pump will extract the liquid from the water. Okay, so this is one of the practical application of this, the same thing. Okay, now media for gel removal. So this is important in the paint industry because the gel has to be removed to get a good paint quality. Now gel is likely to get deformed under pressure. So whenever this filtration takes place, so that must be operated at lower pressure so that it will not deform. It should not, because if it is not deformed, then obviously it can get arrested very easily. Okay. See, if you are going for high stress, what will happen? So it will push through the media because gel can take any form. It can be pushed through the media. But if you operate it at a lower pressure, whatever will be the form, that will be retained. It will not be pushed through the media, okay, by taking a different shape. Otherwise, if you are having the gel which don't have any specific shape, if you apply high pressure, what will happen? Through the pores, it will get deformed and it can pass through the pores. So whenever the gel has to be removed, you must apply lower level of pressure for the removal of gel. So this is another technique, and extraction technique is that, for example, the coffee bag, tea bag, okay, water is moving in, moving out, but you are not that solid particle is there intact. Okay, so only the liquid extraction will be there out of the bag. Now electrofiltration, this is very much applicable in the case of drug development because particles are negatively charged. That's what I mentioned. Very small particle in liquid have a negatively charged. Okay, so it can be captured by attraction of a positively charged in a filter. So we can develop the filter which is having positively charged, or you can say zeta potential. By this charge, it can attract the very small particle, and these anionic particles are very much damaging for the human health. So this page obviously will be very costly because if the particle size is very small, it will be very difficult to remove it by some other means, by mechanical means. So this is one of the technique, electrofiltration, by means of which you can remove the solid particle. Now if you see the classification of solid and liquid filtration, see this part is basically separation, not the filtration. Okay, flotation, sedimentation, density separation, this whole part comes under the separation. Again, if you see this part, centrifugation, separation by electric magnetic field, electroosmosis, magnetic separation, electrophoresis, these are all again separation. Only the media is required for this whole application. Okay, the inner center one. Center one is where we are using the filtration, and then the role of filter media is very important. So here we can have the media where the depth filtration is important, surface filtration. Surface filtration can be further categorized as cake filtration, tangential filtration, dead end filtration, and so on, so on, and so forth. I'll show you one by one, because we must have understanding about the media filtration and how it takes place, because in different cases the mechanism governing the filtration will be different. Okay, their mechanism will be different, because if you are fundamentally strong, for example, okay, we can venture into any filtration aspects. Okay, provided we must have proper understanding. Before we move further, we must have understanding about the how to define the efficiency. Okay, this is a simple setup. In means the particle concentration in terms of number in the upstream side. N out is the downstream side particle concentration. Okay, so N in minus N out divided by N in into 100, that can give you the efficiency, a simple term. Again, if it is on the basis of mass, so particle concentration in the incoming, in the upstream side, downstream side we can have the particle concentration incoming side. Now the point here why it is important, if you are going for clarifier, we can use the number basis, because the particle can be counted. Okay, but suppose if you are talking about the sludge, in sludge it is not possible to go for this sort of expression, because number cannot be counted in the case of sludge, because this the solid portion will be huge, number is huge. So in the case of that application where the solid content is more, we cannot make use of this equation. We'll have to make use of the second equation. Sorry, we can make out of this equation where the solid content is more. Okay, we cannot make use of this. In that case, if the solid content is less, in that case only we can go for this application. And pressure differential is one of the very important parameter, the pressure difference in both the sides. Okay, and filtration velocity is defined as the total area divided by the area. Yes, now the same thing I am showing with some picture, because just now I have explained the depth filtration and surface filtration. Surface filtration, blocking filtration, cross flow filtration, and cake filtration is there. Okay, cake filtration can be further categorized as press filtration, vacuum filtration, pressure filtration, and centrifugal filtration. So cake filtration comes under the surface filtration, but this is the further classification for cake filtration. Okay, so blocking filtration is one kind of filtration, I will explain it, and then the cross flow filtration. Now blocking filtration, you can see that making tea would be blocking, because you are separating the larger size of the particle or material from the water. So that is a kind of blocking filtration. Brewing coffee, okay, membrane filtration is also a kind of blocking filtration, because membrane we talk about the membrane size, pore size, okay, and relevant to the contaminant size. So that is a kind of blocking, because the particle size is more than the size of the pores. So that is a kind of blocking filtration. Okay. Now here if you see, the other definition is the cross flow filtration. Okay. Cross flow filtration, because the liquid is flowing in the tangential manner. Okay. In cross flow filtration, it is flowing in the tangential manner. I will show you the picture, then it will be more clear. Okay, so one is the dead end filtration. Dead end filtration means fluid is flowing perpendicular to the media, and tangential filtration means it is moving along the media. Blood filtration is basically comes under the cross flow filtration. All ultra membrane and all the membrane function basically comes under, like reverse osmosis, all comes under the tangential filtration. Now you can see that how the drum filter works. So this is also cake and vacuum filtration. inside there is a vacuum, okay, and vacuum is not active in this zone. That's why it is disposed of. Rather you are having the pushing by air. In certain zone the vacuum is active, okay, as the drum is revolving, so it can, you can see from this picture. This is the another module, another development for better cake discharge, because instead of knife, because knife can damage, so people are using this sort of technique also. This is the other modification. Okay, so one is the vacuum. By means of vacuum you are separating the water from the solid. Okay, now another, if you see vacuum, again this one is also the vacuum filtration, but it operates in a different mode. So there is a disc of a particular shape is there. See, vacuum is always active in a particular zone. Up to a particular zone, then it become inactive. You can see here how the filter media looks like. Yes, yes. You can see that how the filter cloth look like. Here you can see. You can see here it is very clear picture. Each and every part is independent. Okay, so it is basically mounted over a frame. Okay, and inside you can have creating vacuum. Inside you, if you are creating vacuum, obviously sludge will be on the side. I mean the solid particle will be deposited on the surface. Okay, once it is deposited on the surface, some part the vacuum is active, and whenever it is moving towards the other side, the vacuum becoming inactive. That's why the dislodgement takes place, similar to that of drum filter. So that is the cloth filter cloth exchange. Okay. Now we are moving to the pressure filter. Now question may occur, then why we are talking about so many types of, as I already said, in liquid filtration the complexity is more. You are having more variety. Why you are going for pressure filtration whenever you are having the vacuum filtration? Because if the sludge content is further higher, we cannot work it with the vacuum filtration, because pressure filtration in fact is more effective as compared to vacuum. Pressure is more effective. Either you can use the gas pressure is not so effective, so we go for mechanical pressurization system to compress the cake. You can see over here how it operates. So here you need to have the mechanical pressurization. Okay, so if the sludge content is very high, removal of liquid will be more difficult. Vacuum will not give you the proper solution. In that case, you will have to pressurize it. So here if you see, it is pressurized and the dry cake is disposed on the other side. So it is basically a batch process. Initially, it is not a continuous process. Like the drum filter, if you see, it is a continuous process. Okay, continuously. Like the disk process, it is a continuous process. But here it is a batch process because initially it is pumped inside the chamber, it is compressed. Okay, and dry material is coming out as the conveyor is moving. Okay, initially the conveyor is static. In the conveyor, you are having the textile material over it. Both sides you are having textile material. And if you compress the cake, compress the material, what will happen? It can compress the cake, the solid will be inside, the liquid will be moving out through the textile material. Okay, so liquid you can take it out, solid cake will be inside, and then this same material, textile material, will act like a conveyor. Okay, it will distance, it will make it distance to a certain degree, then obviously it will move so that dispose of cake will take place. So basically it is a not a continuous process, it is a batch process. So initially he mentioned about the batch process and continuous process. So this is the distinction between the batch process and continuous process. People always prefer the continuous process, but certain cases we may have to go for batch process wherever it is required. Now this is the, I will end up by because I will continue from here. This is the way of classified. Okay, this is one is the particle capture entrapment, because I have already mentioned the other mechanism also, adsorption, absorption, coalescing. Okay, here I am only focusing on the particle capture entrapment. So single fiber theory impingement, that plays a little role, as I told, in the case of liquid filtration. Under single fiber theory, you can have the surface filtration and you can have the depth filtration. Now you can see the depth filtration example. Clarification filtration is basically, majorly it is depth filtration, clarification filtration, because once the lifetime is over you can throw it, because clarification filtration is 1% weight by volume. Okay, so once the lifetime is over we can remove the filter. So depth filtration can be applicable only when the solid content is much lower, then only we can go for depth filtration. Otherwise we will have to go for surface filtration. In surface filtration we can have the blocking filtration or straining filtration or dead end, like the coffee or tea I have just mentioned, straining filtration, blocking filtration or dead end filtration. Okay, cross flow filtration. Okay, dead end filtration, the fluid is moving across the plane. In the case of cross flow filtration, the fluid is moving along the plane. And another important category is the cake filtration, dead end filtration. So gas pressurization system will be there. It is not so effective whenever the sludge content is more. Then vacuum filtration. Then we'll have to go for mechanical pressurization system and centrifugal filtration. So both are equally good. For high sludge content, we can go for either. See, one of the point I like to mention, centrifugal filtration is possible with media, without media. If it is with media, okay, I am talking about centrifugal filtration with media. Maybe Dr. Choi will be highlighting the centrifugal filtration without media, but that is the separation, not the filtration. Okay, here I am talking about centrifugal filtration where the media is used, because we are taking the help of both. We are taking the help of centrifugal force, okay, high centrifugal force, as well as the media role is important. So centrifugal filtration. So whenever the sludge content is more, we will have to opt for mechanical pressurization, pressure filter, or centrifugal filtration. These are the options. But if the sludge content is low, in that case we can go for vacuum filtration and gas pressure filtration. So I think, yes, depth filtration means particles has to be arrested up to a certain depth. For example, this is used for liquid filtration. Okay, so particles level will be very low, and this material is not the cleanable type. You don't need to clean it. Okay, what will happen if you see the household water, the contaminant level is very low. Okay, we can have this sort of cartridge in household, but it is in a smaller size in most of the cases. So what happened, the liquid will be flowing from inside to outer side to inside. So particle will be captured not on the surface, they will also capture inside the depth. Now question may occur, that why don't we make it very compact so that on the surface it will capture. So if it is captured on a surface, pressure drop will also increase. Unnecessarily, why we make the filter such that it will capture on the surface? Although it can be captured on the surface, but we don't want that. We want that it must be depth filtered. At a certain depth, the particle must be captured. Because whenever we talk about the depth filtration, we always try to reduce the energy requirement. Because structure will be relatively, see if you see the compactness, relatively not very much compact as compared to surface filter. If you see the surface filter media, that is very compact, because you want that it must be deposited on the surface, because if it is going inside, because the sludge content is very high, your contaminant level is very high, so life will be reduced drastically. Similar is in the case of automotive. In automotive also, if you see after the 6 months you need to change the cabin air filter. Why? Because till that time it can arrest the dust. You cannot make the automotive filter very compact. If you make it, obviously energy cost will be higher. So both way you need to have the balance. Okay. So if you are going in the mode of depth filtration, pressure requirement will be lower. Pressure requirement will be lower, and you don't have the problem because you are replacing anyway after 6 months. So all the air conditioner filter, these are all operate under the depth filtration mode. Whereas the industrial filter operates, if you see the industrial, I am saying that air filtration. Industrial filter operates under the mode of surface filtration. क्योंकि वहाँ पे surface the quantity of the dust will be 600 gram. In the outside area, we can expect 15 microgram of dust. We expect. That's why it has to be read very carefully, because in Delhi it reaches 900, 1000, okay, 1600 microgram range. So if you see the world, US, maybe 6 microgram, they are sitting in the place in the level where the microgram of particle matter is present. To PM 2.5 is 6 microgram only. PM 2.5 means 2.5 below 2.5 micron. 6.6 microgram per metric cube. In Delhi, it could be 1900. You don't know what, because it became a gas chamber, people used to say. Okay, that is the thing. Okay, anyway, what I am trying to point out, if it is going for depth filter, you will get the benefit of energy, because unnecessarily you don't have to compact the material. Okay, so that it can be deposited on the surface. And whenever you are going for surface filtration, cake filtration, we try to dispose it of. Cake is deposited, we try to dispose it of in the cycle. Okay, again it can be, that is the disposing of means we are regenerating the material. Okay, again it takes part in the filtration process. So I think we can take more 5 minutes more. Okay, single fiber theory, if you see, normally we say this is the single fiber theory. Diffusional deposition. Okay, this is the inner side. I am showing the cross section of the fiber. Okay, this is the inertial impaction. Fiber, I mean particle, because this is proposed by one of the chemical engineer long back. But point here is that we cannot explain the mechanism in totality by single fiber theory. That is the problem, because I also published one of the monograph subsequent to that long back. But here the role of fiber assembly becoming very important, because single fiber theory up to a certain extent can explain, but beyond that it cannot explain fully that filtration theory. That is the problem with single fiber theory. Now single fiber theory, normally if you see but it is very important. Concept is very important, but it cannot, if you use the single fiber theory, it can explain everything. It cannot. It is having limitation. For air filtration it is still okay to certain degree, but liquid filtration, because of the viscosity, there will be seepage, direct penetration, everything can happen. Okay, so you cannot straight away explain it in terms of single fiber theory. Now let us look at single fiber theory. Diffusion and deposition, zigzag motion, as I told you in the case of SARS virus and all these things, small particle, it can show you the zigzag motion. Inertial impaction means because of the inertia the particle try to move straight, but air is moving across. See, the air is moving across, but air will not able to disturb its movement, because air will always try to take this particle, but because of the inertia it will move straight, just like you are moving in a bus and bus is just turning by 45 degree. Okay, just like that. So it is not being able to flow the path of the air. So that is the inertial. And direct interception, inertial impact interception means the path will be to certain extent will be governed by the air, but the deviation will not be sufficient. So it will be captured by particles. So in the second case, the particle size will be smaller, relatively smaller as compared to this. It will get deviated, but the deviation will not be sufficient. That's why it will get captured. It is also possible to capture by electrostatic force. Many places the people try to develop the electrostatic media also, but the problem here is that initially it will function, but after a certain duration it will not function. So that is also a commercial aspect of selling the things. Okay, but it will not function after a certain period of time. Charge on the fiber surface, so that also can capture the particles. Okay, so this is the single fiber theory. Separate way I have shown you: diffusion, electrostatic attraction, gravity. In the gravity case, although it is not interacting, but in the outstream side you will not get this particle. That's why it is also being counted. If you count it by number, it is also getting counted as because it is not come on the downstream side. It will fall. Okay, so gravity, that is why counted. Otherwise, it is not interacting directly with the fiber. And it is the common combined efficiency. If you see combined efficiency, that's why the people always test. That is the logic that why the people test at 0.3 micron whenever the filter are being tested. In the case of media testing for gases, it is tested at 0.3. Why it is tested at 0.3? There is a logic, because it can give you the minimum efficiency at 0.3. If you can ensure the minimum efficiency, higher efficiency is guaranteed. If you can 99% efficiency at 0.3, obviously higher value or this side will be always better. Okay, so that's why the people try to find out. That is why MERV, try to find out how the MERV is measured, what is the classification procedure for MERV. Now the point I am trying to say, that if you can ensure smallest particle capture efficiency, smaller than that, larger than that, we will always get higher efficiency. That is the logic that why we go for 0.3 micron testing. That is number one. Number two, whosoever don't have idea about the filtration, what the people usually say, smaller the particle, lower will be the efficiency. That is the common idea. Okay, I can say it is not like that. Otherwise, you cannot get prevented yourself from SARS virus, because it is too small. It could have penetrated because it is very, very small as compared to the pore size. So this common logic is wrong. Whenever we talk about the smallest the size, lowest will be the efficiency. It is not like that. So this idea is very important whenever we talk about the single fiber theory. And Brownian motion obviously in the liquid will be very slow. Okay, it is not be, again whenever we talk about the single fiber theory, it having lot of impact on the size of the particle, velocity of the particle, okay, temperature of the stream. Okay, if you change the velocity, the particles which are showing the Brownian, may they start showing the interception. Okay, so that can happen. So it is not that it is an ideal situation that 0.3 always will get our best, but usually whenever in a common case we can get 0.3. Again, under the static environment it will change. So there could be lot of other parameters which can change this value. Now you can go through this Brownian motion in liquid that has been stated over here. High viscosity slows down Brownian motion. Okay, in a air Brownian motion will be more as compared to in the liquid. Now here this is the concept for surface filtration, depth filtration. Depth filtration means surface filtration will be on the surface. Whenever I say surface filtration, it is not that you will get 100% surface filtration. To certain extent, depth filtration is inevitable. Again, whenever we will go for depth filtration, certain amount of surface filtration, this is the philosophy. According to that, we make the material. But if you say that this is the surface filter, for example, I have shown you a surface filter media, that doesn't mean that it is giving you the 100% surface filter. Not like that. That's why clogging is there. That's why the life is a concern, big concern. Okay, because some amount of depth filtration will be inevitable. Okay. So with this, I think I am closing for now. Okay. So tomorrow, I mean, I think in the morning class, I am having the morning class at 9:30. So from 9:30, I'll continue. But although I am having many slides, so from on the morning, I'll